Hi, welcome class. This is Math 3, Unit 1, Day 6, Density. If you're in another math class, you might be doing this on Day 7, but regardless, we're going to be talking about density. And I'm sure if you heard the phrase population density or just something that's densely populated, something that takes up a lot of things in a small space, that's considered dense. So as far as our geometry unit is concerned, when we're calculating density, there's two things that we're going to look at. We're going to look at the mass, which is the weight, and we're going to look at the volume, which is how much space something can hold. So think of density as just mass over volume. You may be asking yourself, what is this heart with the line drawn through it supposed to represent? Well, think about the top half of the heart being the M for mass, and the bottom being the V for volume. You can thank Kelly Wilson for making that little visual to help you remember that. So it's mass divided by volume. Some common units we're going to be talking about are grams per cubic centimeter. Cubic centimeter is just the representation of volume in 3 dimensions. And also maybe grams per milliliter. And the milliliter is equivalent to a cubic centimeter, but a lot of times we use milliliters for liquids and cubic centimeters for solids. There'll be some other units too as we do conversions as they come up. So just be on the lookout for those. And let's get started. Hopefully after these 5 examples, you'll be able to do the example the problems from the assignment well. And of course, if you have any questions, please ask and I'll be able to help you. So let's begin. All right, so our first example looks pretty basic. It says a student measures the mass of a 10 centimeter block of brown sugar to be 15.6 grams. What is the density of the brown sugar? Well, we have the formula density equals mass over volume. And if you're careless, like I was the first time I tried to do this video, I actually said, okay, that must be the mass and that must be the volume. But look at the units really closely. This actually is the volume. Centimeters cubed is a 3-dimensional unit. It's volume. And if you look at the wording, it says a student measures the mass of it should be a 10 centimeter block of brown sugar to be 15.6 grams. So the mass is actually 15.6 grams. So we're going to substitute 15.6 in for the mass. And the volume is 10 centimeters cubed. You can write the units right over here, but at the end we'll just put the unit in as we circle our final answer. So this is a basic problem. This is just division. And of course, you're welcome to use your calculator. I know that when I divide by 10, I'm just moving the decimal over. So 15.6 grams over 10 cubic centimeters is 1.56, and we write grams per cubic centimeters. And that is our density. And that's all there is to it for that one. All right, so look on to example 2. Of course, you're welcome to pause the video at any time if you need to write something down or rewatch it. But I'll move on to example 2 now. All right, this says a chef fills a container with 52.6 grams. Again, the grams is going to represent mass. So I'm just going to put a little M there to remind me that that's mass of cooking oil. The density of the oil, so this is my density, is 0.88 grams per milliliter. We want to find the volume of the oil. So using our formula again, D equals M over V. We don't have the mass and volume. We do have the density and we have the mass. So we'll substitute those two numbers in for D and M and solve for V. So rewriting this, I'm going to say 0.88 is equal to 52.6 divided by V. All right, so we're trying to find V. We do want to get V by itself, but we do have this 52.6 above it. So we are going to have to multiply both sides by V so that the V here cancels out. And when you do that, that's going to be, we write 0.88 V. V's are gone, so it's going to be equal to 52.6. And to solve that, we would divide both sides by 0.88. And off the top of my head, I couldn't tell you what that is. So I will use my calculator. Oops. 52.6 divided by, don't really need the 0, but you can put 0.88 in the calculator if you'd like. And that's going to give you 59.772. I'll just round that to the first two decimal places. So my volume will be 59.77. And the unit on that, since the density was grams per milliliter and the mass was grams, the volume is going to be in milliliters. So that is my volume, 59.77 milliliters. You're welcome to pause that example and rewatch it if you need to. Moving on to number 3. Another density problem. This time we're given the density again. So we do have D. Density of a cube is 1.54 grams per cubic centimeters. If one side of the cube is 5 centimeters, what is the mass of the cube? So this situation is a bit different because we don't have the volume, we only have one side. But if you remember from a cube, the volume is just the side cubed, side times side times side. That's basically just saying, you have a cube, all the sides are congruent. Volume of a box, as you know, is length times width times height. So if you just say 5 times 5 times 5, or 5 cubed, you'll get the volume. So that volume is going to be 5 cubed, which ends up being 125. If you just want to double check that, you can do that right there, and you get 125. So there's my volume, 125, and that's going to be in cubic centimeters. Since we have the density and the volume, we're trying to find the mass. We'll plug it into our formula. This time we'll plug in the 1.54 for density and the 125 in for the volume. So I'm going to rewrite that. Here's my density. I don't know the mass, but I do know the volume. And like the last problem, we do want to multiply by this number on the bottom to solve for the top part of that fraction, the numerator. So I'm going to multiply both sides by 125. Those will cancel those guys out. And let me write that a little bit nicer. 125 times 1.54 is your mass, and let's see what that comes out to be. So you get a mass of exactly 192.5. And what are the units on that? Well, the units are grams. All right, the density was grams per cubic centimeters. The volume was in cubic centimeters, so the mass is going to be in grams. So I'm going to put a little g there. And there's my answer, 192.5 grams. All right, moving on to example number 4. All right, now we're talking about cylinders. So the mass of a cylinder, there's your M, 900 grams. The cylinder has a diameter of 10 centimeters and a height of 20. Find the density. Well, we need the volume, not the diameter and the height. So we got to go back to our volume formulas and figure out what the volume of that cylinder is. Anybody remember the volume of a cylinder? Pause now to look it up if you'd like. All right, so that volume formula you should know is pi r squared times the height. R, we don't have r, we have the diameter. So if the diameter is 10, The radius is going to be half. That's going to be 5. And we have the height, so we'll plug that into our formula. Pi times 5 squared times 20. And let's see what that comes out to be. There's the pi button right there, second exponent. Pi squared is 25, or 5 squared is 25. If you want to be lazy, you can just do 5 squared. 1570.796, so I'll round that up to 0.8. So my volume is 1570.8, and that's going to be in cubic centimeters. We have our mass. We want to know the density. So that's a straight plug into the formula. Mass divided by volume, which is going to be 900 divided by 1570.8, which ends up being, why is it doing that? 900 divided by 1570.8. All right, finally, so our density is going to be 0.572956. We'll just say 0.573. 0.573. If you want to put a 0 in front, that's fine. And the unit's going to be grams per cubic centimeter. So G over cm cubed. All right, there's one more example on there. I'm going to start it, and if I run out of time, you can see it on the next video. So pause if you need to.